morning we talked about plant health, and then we went into human and women's health. Even women are with humans. I didn't mean that. And now we're going to talk mostly about children's health. And what we're going to use is the study that Asa, Kim, and I have been part of for 25 years, which is the Chamaco study. I think it's fair to say it is world famous because it's one of the only studies of an agricultural population anywhere in the world, and it happened of children, and it happens to be right here. So I'm not being like backpacking, you know, it's really true. And so we wanted to tell you about the study that's actually happening in our community. And so we're going to give you a background. And Asa, we're going to be going.
I'm going to go through a few slides fairly quickly because it duplicates a little bit what we heard at school. So, we heard about pesticides. We learned about what pesticides are. They kill pests, they repel them, they control them. Also things like plant regulators and stuff like that. Mosquito repellent is actually regulated as a pesticide too. But anything used to manage pests. You've probably heard of all these things: herbicides, fungicides, things that kill algae. All these things are regulated as pesticides. Where they're found everywhere. In food, water, in our classrooms. I've done a lot of work looking at pesticide use in child care facilities and schools. Generally, you find them everywhere. Every house we've gone into in this municipality, and we've measured pesticides. Measured pesticides in house pests and things like that. Every sample we collect, we find pesticides, both home use and agricultural pesticides. We heard about this. We've gone into hundreds of houses in the Salinas Valley, and we've done things where we measure pesticides, things like house dust, or white samples. In every sample we've ever measured, we find pesticides in both home use and also agricultural. I'm going to skip this slide. We've heard a little bit about it, but just kind of an example of kind of how bad things can get. Lead, arsenic, you know, two materials that just make me cringe. And these were widely used as a pesticide early on, and very persistent, obviously very toxic. And these were the kinds of things that he referred to. A lot of the early pesticides were inorganic, so they were elements, they were minerals. And then we kind of moved into the DDT and more organic chemistries, organic meaning carbon compounds that we use today. And we already talked about DDT, silent spring, impacts on birds. One thing to mention too is he mentioned that DDT was very persistent, and it also tends to dissolve into fat tissue, so fatty tissue. And this is where we get this concept of what we call biomagnification, which was a big problem with DDT. So it gets in the water, gets in the phytoplankton, gets in the zooplankton, which eats the phytoplankton. Then small fish eat the zooplankton, big fish eat the little fish, and then birds eat the fish. And all the time, all this material is getting concentrated up the food chain. And this was actually, this whole process of biomagnification is actually identified up in Clear Lake. In the 1960s, when they were spraying DDT for a fly, black fly, for the tourists, and people didn't understand why the birds were dying. And so that whole concept of biomagnification was actually developed by some professors at UC Berkeley looking at Clear Lake. So what happened is, when DDT got thrown out of agriculture in 1972, there was kind of a series of pesticides that had previously been developed, but they went into much higher use, in part because they were less persistent. They were also more acutely toxic. So they could make you, as a human being or a mammal or a bug, they were very effective at knocking those bugs down and also making people sick, even with short-term exposures. You couldn't spray this into people's hair, like we saw with the DDT, but they were less persistent in the environment. And so these are the very common classes now that are used particularly for insecticides: organophosphates, carbamates, Pyrethroids you often see in home compounds. These are actually synthetic derivatives of a natural pesticide that's in a flower from Africa. And one of the newest ones on the lot is the neonicotinoids. I don't think we'll have time to go into that today, but well, I think we'll record a version of this on Zoom for you. But the whole fuss with DDT led to kind of our modern registration system. So now under FIFRA, the Federal Insecticide, Fungicide, and Rodenticide Act, there's a requirement that for new pesticide to be used, it goes through a registration process. And that involves evaluating toxicity, exposure, risk, and food tolerance, and establishes kind of the parameters for its use. And many of our older pesticides have not necessarily gone through a re-review that has the depth and breadth of a modern registration practice. But as they get re-registered, they'll often go for that review. And in some cases, pesticides get thrown off the market. We know that pesticides affect workers. We've heard about that. Some of the things that can happen are neurotoxicity, impacts on breathing, nausea. Many of these are related to short-term exposures. And we have a number of poisonings on a regular basis in California. 2018, we had around 1,000 cases of pesticide illness. About 300 were associated with ag pesticides. I'm not going to go into a lot of detail here, but again, we'll present some more information on. I think I'll do a Zoom recording, and then here's some links for some of that information. We've been particularly interested in impacts on children. That was our focus in our initial funding, and I can't say stronger words about how important this particular book was, Diets of Infants and Children. Report. And that really set the tone for understanding that children were more vulnerable than adults to environmental chemicals. And in particular, our pesticide regulation system did not protect children. So this led to an evaluation by EPA in 1995. And then out of this book came the Food Quality Protection Act of 1996, which was passed unanimously by a very divided Congress. But it required EPA, importantly, to look at different sources of exposure, but more importantly, to address the specific vulnerabilities of children when we talked about regulating pesticides. And this was revolutionary. And in the decades since, it's also changed how we evaluate other chemicals. It's kind of migrated from this first work with pesticides. Now, when we talk about any sort of dangerous chemical, we have to think about the specific vulnerabilities of children. And that all derives from this work on pesticides. So why do we care about pesticides in children? Children have higher exposures than older kids. Young children have higher exposures than older kids and adults per unit of body weight. And there's a lot of reasons for that. They're in frequent contact with the ground and floor, lots of hand-to-mouth behavior. Importantly, they eat, drink, and breathe more for each pound of body weight. That's one of the key things. They also spend a lot of time indoors where there may be contaminants like pesticides and house dust. And also, of course, they don't always read labels and they can get into the cleaning supplies or bleach under the sink or pesticides. This is something you can use with your students. We have other graphs like this, but kind of what this shows here is that the ratio of the surface to body ratio when you're young, a newborn, is very high. It's around 0.07. Don't worry about the numbers here. But as you get older, by the time you're an adolescent or young adult, it goes down to about half the level than it was. That ratio goes down to about half the level than as a newborn. So when you're in these age categories, if you're spending time on the floor, you have lots of surface area relative to your body, you're getting pesticides on your skin from house dust and things like that. So you're getting more of that into your body. And this kind of gives you a sense here, a much bigger percentage of this little kid is covered with the rectangle here compared to the adult. And that's roughly proportionate to the higher exposure of kids to adults. not only do kids get exposed more, they're more susceptible. So natural barriers like the blood-brain barrier are not necessarily fully developed. So chemicals that can get across that barrier can get into the brain and disrupt development. We also have metabolic pathways that are not yet fully developed. For example, we'll talk in a bit about something called peroxidase, and that's an enzyme that actually takes some of these organophosphate pesticides and breaks them down and gets them out of your body before they can hurt you. And we have found that in young kids, there's lower levels of these enzymes. So you're kind of less able to metabolize and detoxify chemicals and get them out of your body. And then you're also developmentally immature. So your brain is just forming and whoops. Your brain is forming and developing rapidly. And if you get exposed to a chemical that kind of disrupts that architecture, you might not be able to develop as optimally as you would otherwise. Maybe you'll have a learning problem or ADHD or other problem. And there's lots of studies showing that early life exposure to neurotoxic chemicals is associated with some of these problems later in childhood. So out of this kind of milieu of concerns about children, in 1998, US EPA and NIH came together to start these centers for children's environmental health. And Brenda and I and others in the room got together and we wrote a grant, and we've been working on this ever since. That's partly why we're here right now.
This is why we're here right now. So we started in 1998, funding from NIH and EPA to establish the Center for Health Assessment of Mothers and Children of Salinas, which is called the Chamacos study. And those of you know Mexican Spanish, that means kids. So it was a perfect acronym for us. It's a community university partnership. We work very closely with the community. California is a leading agricultural state in the nation. We produce a lot of the fruits and vegetables, and we also use a lot of pesticides here. This is a map of pesticide usage or organophosphate usage in the years that our kids were born. And the intensity of the color means more that was used, but we'll go into that a little bit later. So Salinas Valley, you've heard, is the salad bowl of the nation. When we started our study, about 500,000 pounds of organophosphates, which is the most commonly used insecticide at the time, was used annually, and about 50% of the farm workers came from Mexico. These little dots here that you can probably see represent the homes of the people that were in our study. So we actually could geocode where they lived relative to exposures that would be the pesticides that were being used. The objectives of the Chamacos study were to measure pregnant women and children's exposures to pesticides and other environmental chemicals here in the Salinas Valley, and to determine the relationship with maternal and child health, and to reduce the children's exposure through different types of intervention and educational programs. In 1999 and 2000, we enrolled about 600 pregnant women serving clinics serving primarily farm workers in Natividad and Clínica de Salud del Valle de Salinas. And as you can see, almost all of the women in the study were Spanish speaking. Almost all were born in Mexico. About half had been in the United States for less than 5 years. We never asked documentation status, but we believe that between 50 to 75% of the women were undocumented at the time we enrolled them in the study. Almost all were living within 200% of poverty, and the reason for that is, as Charles mentioned earlier, we could get pregnant women, even if they were undocumented, during pregnancy because they were eligible for medical care. And so it was a window into the health of these women in a time that we really couldn't investigate any other way. About half of them, or less than half, had less than a 6th grade education. And even if they did not work in agriculture, usually someone in their family worked in agriculture. So these were primarily farm working families. We did not recruit them because they were farm worker families, but we went to the clinics that served those families. Since then, we have followed the mothers and children and added others at age 9. You can see all of the visits. And now our children are adults and they're having children, and we hope to do a 3rd generation study one day. Looking at Kim about that. We have evaluated the health and development of these children and young adults at every visit. We've done interviews, we've tested the children during neuropsychological testing. We actually examine them when they enter puberty, looking at genital development. We've measured their liver function, their anthropometry, their growth and development. We evaluated respiratory function, brain function, risk-taking behaviors, and now we're doing a study on their mothers where we're looking at aging, and we're doing brain MRIs on the mothers that are in the study who are now, around menopausal time. Asa, did you want to go? Or do you want me to go?
Maybe same time.
You want me to do this? I can do this. Go ahead.
Okay, so just to give a sense of some of the kinds of samples and information we collected, we've been measuring pesticides or their metabolites in a lot of different kinds of media. So we've looked at pesticides in urine, blood, and breast milk. We've collected urine from the fathers too. Urine, blood, and breast milk from the moms. And then in the kids, we've collected lots of samples too. Urine, blood, saliva, hair, teeth. Actually, there's been some really interesting work, which we can talk about at another time. We don't have time. And I mentioned house dust. So we've collected lots of different kinds of environmental and biological media. And then we've measured, like I said, pesticides or their metabolites in the samples. Right now, we have more than 400,000 samples stored in our laboratory in Richmond. So I want to introduce here kind of an important, some important information here, because we'll have an activity related to this, which we're probably going to put on recording on Zoom if we don't have time. But Brenda mentioned how there's these little dots in relationship to pesticide use. Just to give you a quick intro here, in California, we have the public land survey system, and you have to report pesticide use in each 1 square mile section. So unique in California is really good information on pesticide use near homes. And some of the work we've been doing to understand exposure is to look at where people live and then understand what kinds of pesticides were used around the home. And we'll actually have an exercise that you can do using a mapping tool and that you can possibly do with your students as well. Again, our initial focus for this research was on organophosphate pesticides. And those were the ones that were very commonly used. They were the first pesticides to be reevaluated under the Food Quality Protection Act. And they're still heavily used in California and around the world. We've looked at these pesticides again and metabolites in lots of media. One thing we see here is that this is Chamacos and this is mothers in the US generally. And these are levels of the metabolites. And you can see the levels in the Chamacos moms were higher than the US as a whole. But it's always struck me as interesting that they're not like 10 times higher, even twice as high. They're about 40% higher. But clearly there were higher exposures to pregnant women in the valley here compared to the general US population. We've measured these in breast milk. This was actually one of the first studies to look at these new modern pesticides that were less persistent. And we found, almost all the samples had some of these materials in breast milk. So we know not only are the kids getting exposed during pregnancy, they're also getting really early dietary exposure after birth. And then I mentioned earlier that we have found these pesticides in every dust sample we've ever looked at, just underscoring that these materials get into homes. And if you have young kids, they're getting into the young kids as well. Diet is important. We did a study here where we had kids eat organic food for a week compared to non-organic food. And then we measured these, we call them DAPs. They're the dialkyl phosphate, or they're organophosphate pesticide metabolites. And you can see here that just, for example, looking at Salinas, they went to an organic diet. There was actually a big decrease in the number of these metabolites in their urine, which kind of underscored the importance of diet as a source of exposure. but there's certainly also exposure going on that's not just from diet. And if we look at Oakland, we did the study in two places to compare a non-ag and ag area. We also see a decrease with diet, although it's not quite as large. And in general, the levels were a little bit lower in Oakland compared to Salinas. So this kind of underscores, one, exposures are a bit higher in Salinas, probably from ambient use of pesticides for agriculture. And then diet also is an important piece as well. And we've done this now with a couple other studies and trying to understand the different sources of exposure.
So I'm now going to give you 25 years of literature in one slide. We then looked at these dialkyl phosphate metabolites, the organophosphate metabolites in the mother during pregnancy. And over the last 25 years, we've looked at it in relationship to the health of their children. And what we found,
Probably
wrong one, is that higher levels related to shorter pregnancies. Shorter pregnancies are not good. Abnormal reflexes in the newborns. We have early reflexes that are supposed to disappear, and we saw abnormalities in that. Poor verbal abilities in the preschool children. When the children reach 5, problems of attention. Poor social skills at age 7. Lower IQ at age 7. Poor executive function at age 12. Poor working memory at age 12. Traits similar to autism at 2 and 14 years. And most recently, earlier onset of juvenile delinquent acts. That's 25 years of literature. I want to just concentrate on this one finding. I'm going to come back to it in multiple different ways. The lower IQ at age 7. So to look at it a different way is if we took the mother's metabolite levels and divided it into low, medium, and high, you'd have about a 7-point IQ difference in the children whose mothers had low metabolites, meaning low exposure, versus those that had high exposure. So about a 7 IQ point difference. For those who aren't familiar with IQ, a standard deviation is 15 points. So this is a half a standard deviation. There have been studies that have shown if you shift the distribution of a population by 7 IQ points, you're going to have a ton more kids with special needs. At age 15, we also decided to look at brain function more directly. And we use this method called functional near infrared spectroscopy. So it's like an MRI, except we're not looking at subcortical function. We're only looking at the cortex. And we're looking at the amount of oxygenation of different parts of the brain, which tell us which parts of the brain are functioning while the child is presented with different tasks. So it's looking at those who are familiar with functional MRI, but in a different kind of way. And so we could look directly at our children who were exposed to organophosphates during pregnancy, more likely at age 15 to show abnormalities in brain function. And what we found was significant associations of brain activation with tasks of executive function. Executive function have to do with organization, they have to do with memory, they have to do with planning activities. And we showed it on a variety of different tasks. Those of you familiar with the brain, particularly in the prefrontal areas of the brain, bilaterally, both sides of the brain. We are now trying to replicate those findings using other measures of organophosphate exposure. Most of the findings on neurodevelopment were from in utero exposure to the mother and effects on the children later on. However, with respiratory function, we saw both prenatal and postnatal exposure to organophosphates was related to children's lung function when they were children. So exposure during pregnancy and postnatally affecting lung function, including asthma-like symptoms. This is an aside. We also saw this with a chemical that is used both in conventional and organic growing. So remember, organic growing does not mean that you're not using chemicals. And that was with sulfur. So sulfur is widely used, and we also saw associations with lung function on the children as well. So health and development of children, as you all know, is related to many factors, not just chemicals. So you're talking about the immediate environment, home environment, as well as nutrition, as well as genes, as well as the larger environment, poverty, acculturation, et cetera, et cetera. So we tried to look at genes, and we genotyped every child in our study and every mother, and looked at enzymes that are related to certain genes that have to do with the detoxification of organophosphates. And we showed the genes that we were looking at were the peroxidase genes that encodes a peroxidase enzyme that detoxifies organophosphates. And we looked at the amount and efficiency of those enzymes, which depend on the genes. So we looked at it in 6-month-olds, when the kids reach 2 years old, 7 years old, and in their mothers in adulthood. And we showed that they had a lower level of enzyme, meaning less able to detoxify organophosphates when they were 6 months old, a little more 2 years. It wasn't until they were 7 years of age that they had almost adult levels of ability to detoxify these chemicals, which means that they were more susceptible to those exposures because they couldn't detoxify them. So going back to that IQ association that I showed you earlier, when I said there was about a 7-point IQ difference between those kids whose mothers had high exposures versus low exposures. Now I'm going to look at that stratified by the mom's ability to detoxify those chemicals based on her genes and her enzymes. Does everybody understand what I'm saying?
Yeah.
Okay. So if the mother had a high level of this peroxidase enzyme, meaning she was best able to detoxify those organophosphates, we now saw no relationship of in utero exposure to the child and the child's IQ. If the mother had a moderate level of ability to detoxify those chemicals, we saw about a 4-point drop in IQ. But if the mother could not readily detoxify those chemicals, the kid had a 10-point drop in IQ. So we see a perfect example of gene-environment interaction. You can't just look at chemicals in the environment. We're not all equally susceptible. So there is an environmental justice issue here. One question that we have asked is what happens when you have a population that's exposed to chemicals, maybe more susceptible because of their genes, and also exposed to social stressors. It's a double jeopardy or maybe in a triple jeopardy. And we're particularly concerned in the Salinas Valley because we already know that this is a population of kids at risk. And one of the main goals, I'm not going to go into this here now, we don't have time, is looking at the interaction between social and chemical stressors and on the health of our children. The one thing I can go into, that 7-point IQ difference that I talked about earlier, if you look at the association of maternal exposure to organophosphates and kids that come from low family adversity, meaning like good family, solid families, you see only a 2.5-point decrease in IQ associated with the organophosphates. But if the kids with high family adversity, you see a much bigger difference. So it's not only genes, it's social stressors, and it's chemical stressors all working together in creating what the impact is of those chemicals. Our work has contributed to the dramatic reduction of organophosphate use in California. We've been told this, so I'm not just saying this. And you can see our kids were born here. This is the decrease, and we can actually go out further, of organophosphate used in California. You can see there's been a dramatic decrease. But there are many, many different pesticides that are being used. This is the organophosphates, but you can see these are the fungicides up here, and this is glyphosate down here. We're seeing overall a decrease in pesticide use in California, but there are some increases. And if you look at the lettuce, like JP was talking about this morning, he says, well, we need fungicides, but we also need insecticides. So not only is there possible interaction of genes and stressors and chemicals, but we're living in swimming pools of chemicals, and many different pesticides we're exposed to. And these are just some of the pesticides, and this is a correlation matrix, a heat map. So the darker the color, the more correlated they are. You don't have to spend time looking at it. The point here is that pesticide use is correlated. And so we need to develop new methods to be able to look at, in populations, multiple different exposures all happening at the same time. So our most recent work that I've done with Charles and Kim and Asa is on glyphosate. And you can see that there's been an upswing of glyphosate, Roundup, in our communities. And this is not all of the use. This doesn't count the use of people that go and buy Roundup and Target. So glyphosate is the most commonly used herbicide worldwide. In fact, this week, the EU decided to, they didn't decide actually on regulations around glyphosate because they're divided right now on what to do. There's been a dramatic increase in use in the last 2 decades here. It's used to control grass and weeds, but it's also used in right-of-way, in golf courses, all of the golf courses in Monterey County, and yards. It's primarily found in grains and legumes, and it's eliminated in urine. And this is important that I'm going to go into glyphosate as a metabolite, and also AMPA, the parent compound. So up until now, you probably have seen in the newspapers, there has been a concern about glyphosate, in particular around cancer. And there's been a number of lawsuits. There's been a Roundup case where the U.S. judge puts a $2 billion verdict against Bayer, and there's been another verdict that's been reversed. So, you know, there's been a lot of fighting around glyphosate, and meanwhile, a lot of it's being used. And again, I just told you, EU made a decision this week, or lack of a decision this week. There was a paper that was done with by a colleague of ours that we work with that showed that adults with a certain type of liver fibrosis and related to fatty liver disease actually had higher levels of glyphosate in their urine than a control group. And Charles came to us with the question, well, I'm seeing lots of kids with fatty liver disease in my clinic. Is it because of the glyphosate that they're exposed to? I'm not going to go into a great deal of detail on this study, but I just wanted to show you how the 400,000 biological samples that we had stored and all of the data that we have collected over 25 years in Chimacos had answered today's question. So, Charles asked the question, is it related to the fatty liver? And we said, well, we have 480 mothers and children in Chimacos where we have residential data, and we have blood, and we have urine. And in the blood, we can measure liver transaminases. We can look at ALT and AST, and we can tell you if they have something like fatty liver disease. And we can pick out those kids that have disease and a control group within our population of those kids who don't have disease. Remember, a number of weeks ago, maybe years ago, we talked about a nested case control design. It's nested inside of a cohort. You're taking cases and controls from those that are in your cohort. And then we measured on those kids their liver disease or liver transaminases. And we also did their blood pressure, their waist circumference, their cholesterol levels, their triglyceride levels, and their glucose levels. By the way, we also measured their body mass, but that's not part of metabolic syndrome. So metabolic syndrome is having 3 out of 5 of these things here. And then we use the pesticide use reporting data, which you're going to have an exercise with online. I don't know what you're going to do with that. And Asa went over the pesticide use reporting data, and we could then geocode all of their residences that they lived in between the mother's pregnancy and reached age 5. We actually have the information up to 18 right now. And we could go back to that big biorepository we have and pull out the urine samples of those kids when they were in utero and 5 years old and 14 years old and 18 years old, and then measure glyphosate and AMPA in those urines and be able to tell you about mother's exposure during pregnancy and the children's exposure during childhood. So how we can use this cohort study to then get information that can be answering today's question. By the way, when we started the study, there was no way to measure glyphosate in humans. This is only a marker that has been developed over the last decade. Okay, so I don't want to go into this in a great deal of detail, but what you need to know is anything that falls beneath this line is a not significant, statistically significant result. This is the point estimate, meaning the average estimate, and these are what we call the confidence intervals, the 95% certainty that something happened in between here. And what you see is that AMPA levels in the mothers, in the children, and in the children in the glyphosate residues were related to metabolic syndrome and also related to liver disease. So we saw an association of child exposure to those things earlier in life and later development of liver inflammation and metabolic syndrome. Remember, up until now, almost all of the research except for Paul Mills' study was on cancer. And so now we're saying maybe the reason why we're seeing this epidemic, maybe, of fatty liver disease is because of the impact of glyphosate. And only additional research can confirm our findings. Kim, with that, I'd like to introduce Kim Harley, who you've seen quietly sitting in our group, who's going to be very much with us for the next few times. She's a professor at the School of Public Health and has been the associate director of this study since almost the beginning.
Hi, everybody. Thank you. So Brenda told you all the science of what we found. Asa showed you what we've learned with regard to exposure. Brenda talked about what we learned with regard to health effects. I also want to talk about what we want to do about that, right? I mean, it's not enough for us just to study all the bad things that are happening with pesticides. One of our goals was also to reduce exposure and figure out how we can, help the health of the community. So one of our ultimate goals, our ultimate goal has been to reduce families' exposure to pesticides and other toxicants. And we've worked at the individual level, the community level, and the policy level. At the policy level, Brenda showed you a slide showing how organophosphate use has gone down. And some of the research that Brenda has shown you has been used by the Department of Pesticide Regulations when they go to recertify pesticides and by the National EPA and that kind of thing. But we also wanted to have a lot of work that we're doing in the community. So as a community-based participatory research project, a community university partnership, one of the things that's been really important to us over the last 20 whatever years is educating our community and our families about how they can reduce pesticide exposure. So through our outreach efforts, Jose Camacho is our outreach worker in Salinas, who's done most of this work, and he has reached 40,000 farm workers and their families, teaching them how to protect themselves from pesticide exposure in our valley. We've also, well, in the middle here, you can see we have community meetings where we talk to our participants about what we found, and try to explain what we've found in ways that are understandable to them, and talk to them about what they can do about it. Because I can tell you, it wasn't a very easy meeting when we had to tell people that their kids' IQ was 7 points lower because of the pesticide exposure their moms may have been exposed to during pregnancy. But it's really important that our community understands what we found from us, that they're not reading about it in the newspaper, and that they get a chance to ask questions. One of the other things that we've done a lot of is working with kids, because we found that when you educate the kids, they in turn go home and educate their parents. And so you can tell a farm worker to take his shoes off at the door, and he may not do it, but when his kid comes home from school and says, hey, I heard if you don't take your shoes off, you're bringing pesticides in, you know, it's an easier way to help us alter behaviors, make behavior change. And then one of the things that we've done in the last 10 years or so is we've done a lot of work with youth. We've done work with our high school council, and then you can see on the left is the ESTA project that we're working with you, because what we really feel like the way to make changes in the community is through the youth, or that's one important way. So we have a youth council. We have a community advisory board of people in our community that sit on to advise our studies. But when our kids were about 9, 10 years old, we realized that one of the constituents that wasn't at the table, was the participants themselves, and they were becoming high school students. And so we started a council where we enrolled 12 to 15 high school students from the community to serve in our youth council. It was a 3-year project. They would come 1-2 days every 2 weeks after school to learn about environmental health and environmental justice, and also work on helping us design some small projects that they could work on and do actual science. And this one here, the youth council, here's our Cosecha Youth Council. The topic that they worked on with us is pesticide exposure to teenagers. I think we have pictures, right? We had these little bracelets. Is there a picture there? There's these wristband monitors that can measure chemical exposures, including pesticide exposures. And what we did is our youth council, they worked for us over the summer. It was 3 summers in a row. Most of them were in about 10th grade when they started, and followed that through till graduation. For the summer, they worked for us as UC Berkeley research assistants, and they did the interviewing. We enrolled, was it 50 girls in this study? Can't remember, was it 100? Maybe it was 100 girls in the study, and they enrolled them. They did the interviewing of the girls. They gave them the bracelets. They explained what they were supposed to do. They went to the girls' homes. They took the dust samples. They was talking about how we've done all those dust samples to measure pesticide exposure. They helped us take the urine samples. Then they talked to, the first year we did the study. In the subsequent 2 years, they were the ones that were communicating the study to the community. Here they're doing, this is their radio novelas. In the bottom one, they were on local news in English and Spanish a few different times. Helped us communicate their findings. So in the second year, they talked about community meetings. In the third year, they did advocacy projects. And I just want to talk briefly about what we found in terms of, this is just one example pesticide. It's a pyrethroid that we found in the wristbands. And kind of not super surprising, we see higher levels in the wristbands of kids who live closer to fields, who say pesticides were used in the home, whose home had an exterminator in it. But what was really interesting to the youth especially was these kind of protective things. So we found that people that had a doormat in front of their house had, if they had a doormat, they had much lower levels. If their home was more clean, they had lower levels. And this was interesting to the youth because it was like something we could actually do. And we said to the youth, you know, you guys are running the advocacy programs in their second and third summers. What do you want to do? And they said, we want to give doormats to people. And so we said, okay. Oh, this is in English. This is the wrong picture, Brenda. The doormat's not written in English. The doormat's written in Spanish. That's just the translation, I guess, for presentation purposes. We literally got 4 tons of doormats from, India sent to us. They came to the Port of Oakland. I said, you guys better be able to get these out because we have so many doormats. I don't want these sticking around, but they gave them away in the community, and it was part of the education of, how can you as a family, protect your family. Their actual version in Spanish. So these are just some of the things that we're doing with you, but just to show you that the youth got really engaged, really excited, and it was a really great way not just to spread the word in the community, but to bring attention to this. They got a lot of press information, press attention. They made, I showed you the radio thing, they decided they wanted to do radio novellas because farm workers are listening to the radio in the fields, and everybody loves the soap opera. So they came up with this idea. They did 7 episodes of a woman named Maria who's always doing things wrong. Like, Maria, don't, let your baby crawl around and when you've sprayed for ants or whatever. So they did this story about Maria, and it was played on radio stations, 6 radio stations in rural California, Washington, and Oregon. Something that I never would have had the nerve to come up with, but they came up with that idea and they pulled it off. We also have a mural. It's right now, if you're in Salinas, on Main Street at the Arts Council. It's on display right now in the window there. But this is a mural that they worked with Jose Ortiz on to show both, farm working, how important farm working is to the valley, but also sort of subtle messages about how to protect yourself from pesticide exposure. It's 30 feet long. It's really long. And as we mentioned, we've contributed to local, state, national, and international policy. Yeah, okay, that's good. There are large group of researchers in Berkeley, and she's wearing the shirt she got at Berkeley, or she's holding the shirt that we gave her.
We need to get a picture of a 22-year-old with that now. So. Jennifer, do you have a question?
I do. It's funny. The first thing I thought, so I have like a doormat and the front and the back. I always take my shoes off when I come in the house.
Good.
My partner who mows the lawn and stuff comes in and out all the time.
Is it the same person that doesn't wash the lettuce?
I'm being ammo here today. But what I want to know is, so we're not too far. We're probably within a mile of fields, and so I'm thinking in my yard I've got all this accumulation, and he needs to take his darn shoes off.
Honestly, one of the best things you can do to keep chemicals out of your home is take your shoes off.
Wash my lettuce and take your shoes off.
I didn't say to wash your lettuce all the time.
How about the effect of pesticides to air? So we may take out shoes, but do we have any research report or data about the effect of pesticides to air?
When we're looking at the organophosphates, the diethylphosphates, we think a lot of it comes through food, but some of it's going to come through air and some of it's going to come through dust. And so it's coming through multiple different vehicles.
And a lot of what's in the air is going to settle down into dust. So one of the things we say to families with kids is that if you have, there's toys up in the yard, well, you can wash them because the pesticides settle in them. I do want to say it shouldn't be the individual responsibility, right? I mean, there's things that we can tell families to do to protect their kids from pesticides, but really at the end of the day, we also are talking about regulations to the higher level.
On the first day that they spread pesticides, we have a regulatory area around the big fields. So we can't say that the effect will be zero, in which we also cautious when they spread pesticides.
You can't say that your exposure would be zero, right?
Right.
You can say that, but we don't know what the effects are. That's why we need to continue to do these studies. I mean, very few pesticides have actually been studied in terms of human health.
So you can decide if preventing exposure is enough for you, or if you need to wait around and see if there's effects on human health.
I think I need to move on.
But most of the exposure is coming through diet. So that means we have to, I say this over and over again, we must eat our fruits and vegetables. It's absolutely essential for our health, but we need to wash them really, really well.
Or we buy organic.
But organic doesn't mean chemical free.
No.
But it
And,
means
and
lower
it still
toxicity.
means, just an aside, if you buy organic, you still have to wash your fruits and vegetables. Because a lot of people think, oh, it's organic, I don't need to wash it, but they think you don't know about the E. coli and everything else that's
Well,
on it.
they're being transported by truck and all of the
Crap.
break add pieces that are lining up on them.
Is there a relationship between the organophosphates and like the glycophosphates that we tend to get in wheat seeds that, you know, some people are gluten free, sensitivities, things like that?
No, I think those are totally different.
Really two different.
Yeah, because organic, yeah,
Yeah, 'cause I know like in like GMO seeds, sometimes they have like pesticides built into them. Don't they?
but not organophosphates. Those are the Roundup Ready seeds,
Yeah.
or they have the neonicotinoids.
No, glyphosate. No,
Organophosphates
It's neonics are the one.
versus, you know, what things you get from eating.
I mean, there's some similarities between glyphosate and organophosphate, but the mechanism of biological action is different. So, the organophosphates inhibit cholinesterase. So cholinesterase carries nerve impulses across synapses or gaps. So if you figure this is the neurotransmitter, and the acetylcholinesterase carries that across, well, cholinesterase. You know, acetylcholine carries it across, and then the cholinesterase stops it. And what happens when you get exposed to organophosphate pesticides is that the acetylcholinesterase get depressed and the nerve impulses become uncontrolled. Right. So that's the mechanism of toxicity of an organophosphate, whereas the Roundup, glyphosate, is totally different.
But we talking about glyphosate?
Well, I was trying to just get, there's a lot of phosphates I noticed.
Yeah.
I was trying to,
Organic
you know,
phosphate and
organophosphates, and then
glyphosate.
glycophosphates too.
Glyphosate, I don't know that.
Yeah,
Yeah.
I think part of it is that, you know, phosphorus is involved in a lot of biological reactions.
But I don't,
So in a lot of chemicals that work in different ways, they are active biologically because they have phosphorus within their chemical structure.
Yeah.
so the way that they operate on, for organophosphates, the way they operate on insects, is the way they operate on humans, so.
It's the neurotransmitters.
Okay, go ahead.
I just wanted to know if those radionovelas are still available for listening to.
We're gonna have to dig them up.
Okay.
Yeah. Yeah, those are about 5 years old now.
Yeah.
We have to go on.
We should,
Well, we're gonna be here, so can you hold on to your question? Because we're so late today. Is that okay?
Yeah.
Okay,
okay,
go ahead.
so welcome.